Welcome everyone. Thank you so much for joining us. It is currently 5 p.m. Eastern Standard Time in the United States, but I know it's the international conference, so welcome for those of you who are up anywhere from 5 p.m. Eastern Standard Time till 2 o'clock in the morning in other parts of the world. So I'm super excited about this panel. This panel is actually going to be a series of UF EdTech PhD students that are going to be doing this panel. So I will move on to the next slide, and this will be an opportunity for each of them to introduce themselves. So we'll start with Brian, and then we'll go to Ray and Song. So if you could briefly introduce yourselves, that would be awesome.
Hey everyone, my name is Brian Abramowitz. I am a third-year PhD student at the University of Florida's College of Education with a focus on educational technology. Beyond that, I work very closely in creating relationships between scientists and teachers and researching the dynamics between those. So my work looks very closely at how to integrate artificial intelligence in science K-12 education classrooms.
Okay, I guess I'm next. Hi, everyone. I am Ray Opoku. I am a third-year PhD student at the University of Florida EdTech program, researching algorithmic bias and fair AI in online learning spaces, essentially. Beyond that, I'm also an AI engineer at the College of Medicine here at the University of Florida, researching the use of algorithmic tools and AI techniques in the area of patient safety. I look forward to this discussion.
Hi, my name is Yukyeong, and I'm a PhD student in the same program as other panelists at UF. My research area is teaching AI to K-12 students in a more inclusive and engaging way, and learning analytics using large data from educational settings. Thank you.
Thank you for the great introduction. So the way this is going to work, we have about 45, 50 minutes. Each of the panelists has a series of slides that I will be advancing. I know it's a little bit tricky because we got the Hula app and we have Zoom. So I will be doing double duty of trying to monitor the Zoom questions and the Hula. If you post questions in Hula, it's actually preferred because that way it kind of stays with the presentation. The Zoom link is going to be closed off. I know we may run out of time, but if you post the questions in Hula, one of the panelists will be able to get back to you and circle back with you on that. So first up, I believe, is Brian. So take it away, Brian.
Hey everyone. So our program, our colleagues recently received a National Science Foundation iTest grant, and that stands for Innovative Technology Experiences for Students and Teachers. As a result of that, we ended up hosting teacher professional development workshops. We leveraged this idea of paleontology and more specifically fossil shark teeth because we knew that was something that our Florida teachers and Florida students had a lot of experience with. They can just go down the street, walk along the beach and find shark teeth. They can go to their local creek and find shark teeth. This is something that we all have some familiarity with here down in Florida. So we had this week-long teacher professional development where we took teachers from all the way in the bottom of the state in Miami, all the way to the top of the state in Pensacola area. We brought all of these teachers together for this incredible AI learning experience. Next slide, please. So as I mentioned before, one of the things that I do in my full-time role, in addition to being a student, is I coordinate scientist-teacher partnerships. So I'm regularly talking to district leaders, I'm talking to teachers throughout the state, and hearing what their thoughts are. And interestingly, many of them are talking about artificial intelligence. Many of them are talking about things like, well, we heard in New York City, ChatGPT got banned and then it got unbanned. We heard that our Google Maps uses AI, but I don't really know how that works. Or we see that when we're typing things or texting things, we see that predictive text come up. And I heard that's AI. But many of our teachers don't actually realize that what machine learning is, what AI is, and how it can be used by experts or really everyday people to solve really complex problems. They don't realize that it could be used by park rangers to detect poachers. They don't realize that the University of Florida is using artificial intelligence all the time with their crop productions to maximize their output and their harvest. And we were also seeing this, as you see here, by some national organizations. National Science Foundation was calling for additional research on AI. Similarly, we have incredible organizations like AI for K-12 who are disseminating and promoting pedagogy related to AI for teachers to use, as well as some curricular resources. And even in the spring, I believe it was March, the United States Department of Education shared a recommendations and insight handbook, a report on what teachers need to know about artificial intelligence, as this is sort of becoming more of what teachers are using in their classroom. Next slide, please. So here's what our workshop looked like. Like I said before, we took teachers all throughout the state as part of this cohort model. We had funding for 3 years, but we're actually going to extend it to a 4th year. We brought all these teachers to Gainesville. We paid for their hotel. We paid for resources to give them once they leave, including shark teeth from the museum collections. We printed them 3D printed shark teeth as well. And then the workshop, all the mornings look very similar to each other. Here at the University of Florida, we have a tremendous number of experts on artificial intelligence. That's a huge priority at the university. So teachers were in a classroom setting in the mornings. They heard from experts. What is AI? How are data used? What do we use it for? What are models? What are the limitations and biases we need to be aware of? How do people use AI? We heard from industry. We heard from academia. And then in the afternoon, we had our teachers put on the student hat. We had our facilitators sort of have an idea of what types of activities the teachers would go home with. However, we saw our teachers as equals. We saw them as colleagues. So although our facilitators had some plans, some activities, some lessons for our teachers, we really wanted to negotiate the meaning of those activities with our teachers. So we had those conversations seeing here, we have this, but you're the expert on your classroom. Do you think this would work? We had them have conversations like, no, this is too advanced for my students. This is perfect. Here's how I might tweak this to work even better in my classroom. Because I don't always have computers in my classroom, I'll have to make these changes. And again, we had our teachers come in with the expectation that they are going to be there from the beginning. And when changes need to be made, we want that to happen. We want to do what's best for them. So those afternoons, those teachers were having conversations with us because at the end of the day, these activities, lessons, modules, etc., curricular resources are what we expected our teachers to implement in their classroom after they wrapped up their time in Gainesville at the University of Florida. So we asked them those questions. How might you share this information with your students? How might you make this accessible? A lot of students differ in what they're interested in, whether they're in Miami or whether they're in Marion County. That's rural or urban aspects. So we wanted to make all this information really accessible to students statewide. And then we showed them exactly what each of our lessons are going to look like. Next slide, please. Here's the approach that we took. There is a lot of different ways that artificial intelligence is being taught in K-12. Some people use NLP, some people use a lot of different methods. However, we specifically focused on computer vision. And one simple way to do that was we used an application called Google Teachable Machine. And as you can see on your screen, we took a very, very basic approach. We wanted our students to feel really good about what they're doing. We didn't want them to feel overwhelmed. We didn't want those feelings of fluster, that emotion there. So we wanted them to feel proud of themselves of what they could achieve. So we specifically, like I said, we're looking at shark teeth. And for the sake of simplicity, we divided it only into 2 classes. Some teachers went above and beyond with their gifted students. However, for the sake of our middle school students, again, we started at a very fundamental level. So we divided our classes into Megalodon and not Megalodon. You can see there's a big difference in the images samples. So we looked at having those conversations of how might this influence the results that you're getting. So we had our students look for files, take pictures of shark teeth. Again, we gave those shark teeth to teachers. We just went ahead and clicked train model. And it took about a minute. And then on the right there, you'll see that our students had the opportunity to either upload a file of a tooth, or they could hold a tooth up to the webcam. And they could see exactly what that machine learning model is doing. And they could see sometimes they're going to get wrong answers. And we have those conversations with students of, what does that tell you about your data? How might you need to redo your model or retrain your model to get more accurate information? Next slide, please. Here's what our lessons look like. We actually started with a lesson model cohort 1, but decided to change it to a module model change 2. We found that teachers were a little bit overwhelmed with the idea of having to complete a whole lesson, but we changed to a module, like I said, because then teachers could sort of plug and play. They could pick which activities work for them. So for example, we changed lesson 1 from a lesson to 3 to 5 different activities that teachers could just choose from. And what you'll notice here is a lot of our lessons range. So we started with the science, we started with the paleontology. What would a scientist, the paleontologist, actually need to do before they could use AI? We start to approach the AI information in lesson 2. How do we take the things that we've been doing with our shark teeth and prepare them for machine learning? Lesson 3, we focused on how do we train and evaluate a machine learning model, even with a simple tool like Google Teachable Machine. 4 was actually, interestingly, the lesson that resonated with teachers the most. In our data, teachers kept sort of repeating this idea of responsible. They only wanted AI to be taught in K-12 science education when it is done responsibly. They kept harping on this idea of ethics and making sure it is done in a responsible way. And then the last one, lesson 5, is when we had students conceptualize their own machine learning model. So a lot of the lessons that you heard about so far were just focused on shark teeth. We wanted to give students the opportunity to come up with their own one. 2 classes. Some of them went to the beach and did shells, this shell or this shell. Some of them were identifying faces, happy or sad. So again, this was a very basic model. And interestingly, many of our teachers from cohort 1, actually all of our teachers from cohort 1, except one that is no longer teaching science, decided to join our cohort 2 and are reteaching these AI concepts. Next slide, please. So we did quite a bit of research and evaluation as part of this project, and we're continuing to do more. I just thought I'd highlight a few of our findings so far. So far we've been looking at things like student career awareness. We've been looking at teachers' AI misconception, and we found there's actually been a huge shift from teachers having misconceptions to more accurate conceptions. So that's encouraging. But you'll see here we found things like, we asked teachers about their perceptions of AI in science education. Here's what we found. More teachers are open to AI in science education. They're open to it. More teachers feel AI can help them teach science. Teachers are more aware of the value of AI ethics, and they're more hesitant. Some of them just want to learn more about AI before they use AI completely in their classroom, but they're more open to it. More teachers feel it's important to talk to students about AI. They realize that this is likely going to be their students' career, whether their students work in the AI sector or they just have a job in the future. To some extent, AI will be within the work that they do, or they may be using applications, computer programs, things like that that use AI, and they want their students to be able to critique and criticize how that AI is being used, so that it doesn't sort of use more of their information than they wanted to. For example, they wanted to critique it, be critical of it. Lastly, their self-efficacy. They are much more confident. They have a higher sense of self-efficacy for integrating AI in middle school science education. So as you can see here, there was a significant improvement in AI teacher self-efficacy. And I'll just wrap up by saying there was a significant improvement in teacher confidence and their ability to help the student understand it better. And last slide, please. So overall, our theme here is the teachers were our partners. Throughout this whole experience, so we had a week-long workshop in the summer, and then the cohort model extended throughout the whole school year. And then in May, when the school year concluded, we brought all of our teachers back to Gainesville, and had a focus group. We talked about what happened. We looked at student artifacts and had conversations together about how those same teachers plan to do it again next year. So one of the things that really facilitated what happened and made sure it was successful were our coordinators as part of the project. Our iTest program funded coordinators, and they were constantly available. Our teachers had a lot of concerns doing this for the first time. Many of them did not even know what AI was coming into the workshop. So our coordinators were available to support them with either research expectations, connect them with an AI expert to help answer their questions. We really wanted our teachers to feel comfortable and confident prior to teaching this information to their students. In addition, we had virtual quarterly check-ins to talk to our teachers about what's going on, how we could support them. For example, even though many of our teachers taught this last year in certain school districts, we're finding that some of those same school districts, unfortunately, are banning things like Google Teachable Machine. So these coordinators and other staff members from the program are working with school district officials to make sure that these tools that have shown great success in teacher self-efficacy and student self-efficacy are available for teachers and students to use. As I mentioned, we had a whole group cohort in June. We talked about what's going on, and as a result, we'd make those changes for cohort 2. We're currently in our second cohort, and we're finding our teachers are much more confident about what they're doing, feel much more prepared. We're using our information from pre and post tests. We have content-related pre and post tests, looking at how students are gaining content information as well as AI skills. Just the structure of a whole support system has been incredibly beneficial for our program. So as I say in this last bullet here, we are increasing our support for teachers. This year, we chose to spend additional funds, hire a teacher leader from cohort 1 to support all of our teachers in cohort 2, as well as we hired a graduate assistant, a paleontology graduate assistant, to be available to serve as a scientist visiting classrooms as part of these teachers implementing their lessons in their classroom. All that to say, we just really wanted to make sure our teachers feel ready, because this is a very new concept to almost all of our teachers. Implementing artificial intelligence is something we're seeing our teachers and school districts do much more and more of, and we just want them to feel ready for it. So with that being said, I want to thank you for your time. I really appreciate your interest in my work.
Thank you very much, Brian. So please, if you have other questions, add them to the Q&A under Huva or into the Zoom chat. So we did have a question from Scott for you, Brian. What do you see as the minimum technological requirements to implement AI at the initial level? Not sure what he means by initial level, but.
So if I'm speaking to the project requirements, there's no requirements beyond having internet infrastructure as well as a computer itself. All you need is that browser. Our teachers did not need to download anything on their computers, and students are just able to use that Google Teachable Machine. That is the application we chose to use in this case. We wanted to expose our students to additional models, but we didn't have them use it. So for example, we had our teachers demonstrate and model RoboFlow. RoboFlow is another one, but that's more advanced. And at the very basic level, we had our teachers use Google Teachable Machine to inform our students of these concepts.
Awesome. So Scott saw I had another question. Brian, if you can respond to that question in the chat so we can move on to Ray. I don't want to run out of time. So sure. Ray, you're up. Go ahead.
All righty. Well, thanks, Brian, for sharing some of the findings from your project. And moving on, we want to, or we do not want to lose sight of the fact that AI and machine learning and all the algorithms are quickly evolving in the realms of education. And as such, there's a need for some of the stakeholders like ourselves and researchers alike to take a step back and begin to understand, as much as we see how beneficial and immense the potential for AI in online learning and education is, we want to also make sure that we understand that, well, these systems can also perpetuate some biases and discrimination if they're not carefully designed and monitored. So setting the stage for how we understand fair AI, fairness in online learning, and algorithmic bias. Dr. Moore, if you can move on to the next slide, we'll delve a little deeper. Well, the notion or the principle of fair AI essentially stems from the fact that AI systems, are systems that we expect to work equally across the board, regardless, in an equitable manner, regardless of race, gender, age, or any other protected class, basically, or characteristics. However, what we get to see beyond, whatever it is that UI systems and AI systems are put in front of us is that, well, digging a little deeper into the back end of the data, we're beginning to see that there's some discriminatory practices that are existing on the back end. In online learning, for instance, there are systems that are incorporating models that predict student learning outcomes at the end of each class session, at the end of the quizzes, at the end of any, level of assessment, which of course is informing live feedback and is informing who receive more attention in classrooms from the instructors and teaching assistants. Fair AI is a notion that says, listen, if we're going to be doing this, we want to make sure that the algorithm is pushing out, equal number or an equal amount live feedback to various individuals, regardless of their groups, right? And a subset of fair AI here is algorithmic bias, which essentially is a notion that these AI systems are producing systematically skewed, results in favor or disadvantage in certain individuals or certain groups, and due to inherent biases in the training sets, particularly, and the decision-making process that went into gathering those training data sets. So we do not want to lose sight of the fact that these are important tools, but there's a potential for misuse and discrimination if we're not very careful. Next slide. So then, why is it crucial, or why is it important that we address some of these algorithmic bias, and why is it necessary that we do so right at the onset, right? We don't want to wait, a few years down the line when large language models and highly predictive models have been incorporated in learning management systems to begin to look back and say, oh, we should have done this better, we shouldn't have done this better, or we should have incorporated this model in this way, we should have looked at some of the metrics that we used to evaluate this model in that way, right? We want to make sure that we start thinking about some of these issues right at the beginning as we launch ourselves into the AI future. And one of the aspects that we pay attention to is ethical responsibilities, essentially that online learning platforms, in addition, in conjunction with educational institutions, should have, ethical responsibilities to provide unbiased and fair educational experiences across the board, right? If you are online, if you are in person, you're expected to receive a similar experience, and the experiences shouldn't be vastly different. Another reason why it's important we start addressing some of these algorithmic challenges is, making sure that whatever outcomes we're getting out of these systems, they are equitable in a way that cuts across board. Because one particular, principle that we keep hearing over and over is that, well, AI systems are going to be increasing in the realms of personalized learning and give each student a unique, individual learning practice or learning process. While that's important and that's true, there's a little issue when it comes to the fact that, well, these students will be getting different, outcomes from the same learning material, which is something we don't really want. At the end of the day, we want to expose students to a variety or a vast range of knowledge and viewpoints. And one last thing, and why it's important to address some of these challenges, is so that we have the trust fundamentally from the public, we have the trust from parents, we have trust from some of our, policymakers, knowing that these models that we institute will not disadvantage learners or will not disadvantage kids in a way that would help but would rather support them and not potentially perpetuate in persisting or existing inequalities, but aim to mitigate or reduce them. Next slide, sir. So then how or why will, how do we want to engage stakeholders across the divide, everybody involved? How do we want to engage them in a way that helps us build a future towards a more equitable and fair, AI approach in online learning? And one of the areas we want to be thinking about is making sure that we include all representatives, basically from various backgrounds, various educational level in the initial decision-making process. The diversity of perspective would help us understand and address some of these biases effectively and sort of enhance the solutions that we come up with in a more comprehensive and equitable manner. Another way to build some of these bridges and include everybody in the AI building process upfront is encouraging open and honest discussions and open and honest discussions. Researchers and computer scientists and AI experts understand that code is human, and humans write code with their own inherent biases and inherent, features and understanding of how, or an outlook of how this world works. And so if we want to make sure that we're building inclusive AI systems, we want to be transparent and communicate at least at the beginning and trust us in the work that we're doing and the systems we're building. And also to make sure that we're collaborating in a way that makes everybody involved. Next slide. So then why are we collaborating on Fair AI? And this is where I propose an approach that I've dubbed co-creation in a way that sort of brings everybody together, including the end user, the domain experts, the ethicists, the legal folks, into identifying and defining clear AI goals, assessing the risk that these systems would lead to or would shape, and in that case help shape and design the system holistically. And I think this co-creation method will sort of help uncover some of the biases and in the early development cycles and ultimately lead to a more fair outcomes. We're also making sure that as part of that co-creation module, we're ensuring that the representatives in the entire set are diverse and large enough. We're making sure that we're vetting the algorithms right at the beginning, so at least we don't evaluate at the end of it, but we start evaluating right when we start running some of those modules, and also continuously assess and correct for biases. And while we're continuously assessing and correcting for biases, we want to make sure that we're providing explanation and justification for each AI decisions, because if a model is ran and the model says a student is going to pass or fail a class, that model is expected to have some Shapley values that would explain why those decisions were made. Next slide. So finally putting a button on the discussion on AI, fairness, algorithmic bias, I implore all of us as we begin to have the discussion and conversation around artificial intelligence in online learning spaces, to begin to think about some of the ethical considerations and biases that these systems are likely to perpetuate, right? In my own research and in the research from my lab, what we're doing is we're taking an online learning platform, and in that platform, what we're doing is we're building a fairness tool, and in that fairness tool, it sort of identifies whether or not different sets of students in the same online class are receiving the exact level or the exact amount of benefits in terms of feedback they need in a math problem, for instance, right? Or any group of individuals, be it male or female, in that same set are able to receive that instruction across board. That doesn't feel like one group is getting more attention from the other group. And even the tool that we build, it's set up in a way that would allow other people from different classrooms to upload their own models and test that against the training sets that we have. I would leave the discussion here on fairness and AI, and I'll turn it over to my colleague, Song, to continue with this discussion. And I look forward to some of the chat where we'll be having in the chat sections. Thank you.
Thank you, Ray, for that. So while Song is switching over and getting ready to share, I had a couple quick questions that have come up that I want to take a moment to answer. The first one is actually for you, Brian. The question is, you mentioned that teachers' preconceptions of AI changed across various cohorts. Did you notice any drastic changes around the past 12 months or so as certain tools have become more mainstream?
It's a great question. We specifically focused on one tool as we did not want teachers to become overwhelmed as there are so many AI tools. We offer teachers the opportunity to use additional AI tools. However, not many of them focused on that. I think many teachers realize that AI is this sort of huge umbrella, that there are so many AI tools, and since they already have so much on their plate as teachers, they just decided to sort of take it one small step at a time and focus on exactly the applications that we were providing for them. And then we'll see as our cohort 1 teachers move on to cohort 2, as they feel more comfortable and perhaps involve additional applications. I hope that answers the question.
Awesome. And Scott, I saw you had another question, but we need to move on. So Song has the time to present, and we will try to circle back and answer those questions then. So Song, go ahead and take it away for us.
Okay. Thank you, Dr. Moore. Thank you, Ray and Brian, for your great presentations. So today I'm going to share some of my experience about co-designing AI unplugged activities for a conversational AI summer camp. So let me give you some context of this project. So it is an NSF funded project called Camp Dialogues. So as a part of the project, we offer the free 2-week summer camp experience for rising 7th and 8th graders. And in the camp, they learn about computer science, AI, and conversational AI, and they have some opportunities to develop their own chatbots that can be integrated in those Google Home or Alexa. So in this context, we for developing the curriculum and the educational technology of the summer camps, we used design-based research. So from 2021, for 3 years, we've been iteratively designed and developed our curriculum and our technology. So in 2021, I'm not sure how many of you have heard of Google Dialogflow. This is a web-based programming, web-based service that people, like usually adults, business owners, would make their own chatbots for their business users, so they can integrate their chatbots for like getting reservations for their hotel, something like that. So we used the Google Dialogflow in our first pilot study year because we haven't developed our own educational technology. But as I said, it is for adult users, not for kids, not for children, for our middle school students. So we developed our own educational technology called Ambi, AI Made by You. It is an easy, kid-friendly interface for children to develop their own chatbot. And as year goes by, we developed our curriculum in a better and more engaging way. So we had, in 2023, which is this summer, we developed more unplugged activities as part of our curriculum. So today's focus is unplugged activities. And have you heard of unplugged activities? Probably many of you have heard of it if you're interested in computer science. So we have CS Unplugged, which is a big initiative that has been introducing CS concepts to novice learners without using computers. So we have list of unplugged activities in the CS education field. We applied this idea to AI education. So we wanted to design and actually like use those activities with the students in our summer camps to introduce AI concepts to novice learners without using computers. So because this is a pretty new and there are not many AI unplugged activities out there, we wanted to, take advantage of this this co-designing process. So we had stakeholders in our summer camp context. We have three big stakeholders in our summer camp. First, learners who are middle school students. We have facilitators who we hired for facilitating the camp. They are mostly undergrad students, and we also have some graduate students. And we have researchers who are like a PhD student like me. And me as a PhD student was not only the researcher, but also a facilitator in our camp context. So we adopted this iterative design process for designing the AI unplugged activities. The first phase we asked facilitators to volunteer if they are interested in designing this activity. So 3 facilitators, undergrad facilitators volunteered to be in the team. So 2 PhD students, 3 facilitators gathered together. We had several meetings about, and we reviewed the literature and existing CS and some of the AI unplugged activities. We reviewed our camp learning objectives, and in the literature, we had some successful CS design patterns. So we utilized those pre-existing resources, and we had some ideation. And the second, we researchers of the same team, 5 people, we developed our instruction and materials, and we want to call it as a prototyping. So we had some instruction and materials, the preliminary versions. And with the facilitators, with the whole group of facilitator, which was less than 10 people, but like 8 and 9 people, undergrad students plus graduate students, we held unplugged activity workshops during the professional development prior to the camp. We tested our activities, and we had some discussions about so we treated the undergrad students as if they are middle school students. We implemented our prototypes, and we had a discussion about what's confusing, or like how it can be more clarified, how it can be improved. And we had some new ideas, or like we had some small clarification about the worksheets, or like, the slides. So I'd like to call it testing and improving phase 1. And in the end, we implemented those activities with the learners, with the middle school learners, and we collected their data, their reaction data, like observation. We had some survey and interviews. So I'd like to call it testing and improving, because this is not the end of this project. We want to keep improving our activities based on this year's students' reaction, so that we can have a better activities in the future. So here are some examples of designed unplugged activities. The first one is user developer agent card game. So the learning objective was, I can identify and explain the user, agent, and developer roles in the design and development of chatbots. So this is very important in conversational AI learning context, because they need to differentiate the roles of user, agent, and developers. And we made it into a card game. So we have 3 stacks of cards. So developers' goals, chatbot's response, and this is supposed to be users' utterances. So, and we randomly shuffle them, and students are supposed to match those 3 intentions of user, agent, and developers. So for example, so this chatbot response is, Tallahassee is the capital of Florida. And the development goal should be an AI that talks about facts about states in the United States. And the user utterances would be like, what is the capital of Florida? So they would match, and it was like a competition between teams. So students would time it so that they can like kind of having fun competing with other teams. We had the second activity was mission agent training. This is about for students to learn how the conversation between the agent, the conversational agent, and user develops depending on the data and the training phrases and how the training of the data works. So basically, we had one student volunteered as a user, the other student volunteered as an agent, and they were given a stack of cards. So in the cards, we have two different cards. We had user questions and responses. And the user questions, we gave them these 9 questions to the user. So the user is supposed to read those questions. And we have responses. So the whole audience who is not volunteered for this activity in front of the class, they wrote the responses. For example, they can say, what can I do for fun in Gainesville? And they can say something, oh, you can go to Flea Factory to play something, or like, oh, there's a theater in Gainesville. So they would write those responses, and the user will read those questions, and we had like 3 different rounds. So in the first round, the user wouldn't, the agent wouldn't have those answers in order. So it was the response cards was in like randomly shuffled. So the user would say, oh, for example, what can I do for fun in Gainesville? And the agent will say something like randomly, like, oh, my favorite song is One Last Time from musical Hamilton, So, and after that, we classify those user questions and the responses in order, and we have those intents to classify those questions and the responses. So nicely organized. And in the third round, the user and the agent will have a nice natural conversation. So this is how they learned about how chatbot will learn from the data. And we have third example, chatbot personality. So we want students to express some of those personality of chatbots and infuse those personalities into the chatbots. So we gave out this worksheet. So students would write their chatbot's personality or like age, their tone, so that they can have some persona about the chatbot. And they wrote their voice customization. So they put gender, like pitch, speech rate. And after that, based on the worksheet, they would act out their chatbot personality. So some could be like a very low, passive or quiet pitch, or some will be very like high, fast speech rate based on the personality they want to express. So this is kind of like acting out, and the audience would guess what kind of personality that this person is trying to express. So there are 3 conversational AI unplugged activities we designed with the facilitators and the learners, and we have the learners' reactions. So to ask about their reactions, we first ask them about what they learned from this activity. So we want to match it with the learning objectives, and we want to see how much they learned what we intended to teach. So for example, one student said, I learned that you need intents to categorize the responses for the agent to respond with a good answer, which is actually a good lesson that they could learn from the mission agent training activity. And there's another one. Oh, I learned the personality of a chatbot can make user feel more like they are talking to a real person, and all those voice customization features determine its personality, which is also aligned with the learning objectives of this activity. So as a second question, we asked them, what did you like or not like about the activity, and how did you change it? So one student said, oh, I like the acting out part of the chatbot personality activity. But with the same activity, the other person said, the other students said, oh, I learned that I'm terrible at acting. So even the same activity can give different learners with different impressions or different reactions. So we learned that, oh, okay, so from now on, we're going to provide students with multiple options for expression, which is actually aligned with universal design for learning principles. So we had those like list of lessons learned from our designing process. And in conclusion, we think involving stakeholders, in this case, learners and facilitators, was beneficial for us to design effective learning activities and experiences. In that, first, it provides us more creative ideas for the activities. So actually, like those facilitators who participated in this designing process really helped us have more creative ideas. So like that was really helpful. And the second, these activity workshops with all the facilitators allowed us to practice our activities, and we found a lot of not really working part of our instruction, or like not clarified enough, So it really helped us to improve our activities. And the third, we could address learners' feedback and improve the activities. Like, oh, in the chapel personality activity, we want students to they give some options, like they could come out and act out in front of the class, or they could just form a small group so that they can act out in a small group, depending on their preferences. Okay, so this is the end of my talk, and I guess we have some...
Song, if you could just leave it on this slide since you're sharing your screen. So thank you so much for that. So I have a question for you from the audience. Do you think these learning activities could be applied in a higher education, such as for a first-year university student setting?
Yeah, it really depends on what kind of learning objectives you are trying to get in that higher education settings. So for example, in our context, it not only depends on the students' grade levels, but also depends on the like learning content that we want to teach. So our activities are really like closely related to the learning objectives of conversational AI. So if your learning context is about teaching the similar or like the same learning content about conversational AI, I think it can be utilized in your context as well.
Excellent. Follow-up question is, where can we learn more about your work, Song?
Yeah, so actually this unplugged activities was accepted to 60 next year. So 2024 60 proceedings will have this paper. And also we're planning to publish this in our website, Camp Dialogue's website, with all those like needed materials and the instruction.
Excellent. Thank you so much for the questions. Let's see. Do we have any other questions? If there's any other questions, please, we have about 4 or 5 more minutes, so you can add them to either the Zoom chat or the Hoover chat, and we will answer as many as we can in the next couple of minutes. You wowed them.
Mm-hmm.
Looks like Brian answered the question he had earlier. Song answered that question. So I think we covered all the questions. So if there's no other questions, again, feel free. You can always add in the Hoover. Hoover stays open after the session. Oh, here's a question for Ray. Hi, Ray. Just wondered if you could share more about your approach to sustaining, triaging, and actioning on feedback for AI systems.
Oh, right. Yeah, that's a really good question. So what what we essentially have done so far is to design and develop a peer, not a peer recommender system, but a recommender system in general, a general recommender system that allows instructors on the platform we're working with, which is called Maths Nation, by the way, allow the instructors to observe on a dashboard how overall students are doing in the class, right? So each student have their predicted score essentially, right? Which would trick, if the prediction says a student is on the trajectory to failing the class, then they're given two options. One of them is to send the student an email through the recommender system that we've created, the dashboard we've created, and the second is for them to reach out to the student directly via direct chat, basically. So in that process, instructors are able to get to students who students who really need that feedback in time and in the moment. But how do we expect this to sustain this approach and this system? It would essentially require buy-in from, various stakeholders, essentially, right? If we put together an instructor recommender system and, we're having pushback from educational leaders and we're having pushback from principals from, various institutions, that essentially is going to put a damper on that progress we're trying to make. So to answer your question in a long way, the sustainability of this technique or this approach essentially requires buy-in from everybody involved, either at the local level, at the district level, and even up to the state level, essentially. I hope that answers the question.
So thank you, Ray. Thank you, Brian Song. Fantastic job. Thank you for everyone who attended. As Grace just shared, the Whova app stays open throughout the conference. So if you have other questions that have come up that you think about, please add them, and we'll monitor that and try to respond as best we can. But again, thank you so much for coming and attend the session, and enjoy the rest of the conference.